Hey everybody, buckle up for Bill's Mathia, as this week we're in part 2 of our 3-part series on averages, which even I can't believe I'm doing this video, standard deviation. Now last week I covered mean, median, and mode, and discussed that our most common metric to define average is of course the mean, and I also introduced a flaw. Specifically, when we start thinking of average as a singular point on our distribution, we then start to have this binary concept of bad versus good. Now, absolutely, if you had to choose between Aaron Rodgers at 64.6% or Jacoby Brissett at 64%, you're going to go with Rodgers, but the difference straddling that average line really is not that drastic. I pointed out in week 1 of this series that average is really a quest to discover what's normal, and therefore identify what's no longer normal. So here's a crude drawing of what we call the bell curve. And to introduce the idea of standard deviation, you can think of it almost like an average layered upon another average. And what I mean by that is we find the mean, and then the standard deviation is really nothing more than the usual amount of distance away from the mean. Let's focus on these specific numbers a little bit and what they mean. For a normal distribution, you're going to look at, again, within one standard deviation, 68% of the population. So this does a really good job of identifying what's normal or what's usual, because most of the population is going to fall within that. Now, pardon the sloppy handwriting, between 1 and 2 standard deviations in either direction, you're usually looking at about 13% of each population, and then about 2 to 2.1% of the population is usually going to be greater than 2 standard deviations away from the mean. Or in other words, what we're looking at is a great way to categorize things as normal, somewhat distinct from normal, and remarkable. And I'm going to use that term a few times today. So yes, there is a formula for standard deviation, and while we're maybe used to numbers and letters for a lot of math, when we start looking at some of these formulas, some of these symbols, is it written in Sith? Who knows? But what we're looking at for this particular formula, here is our mean, here is our values for our population, and we're going to find this distance, square those, sum up all those squares, divide it by the number of items in the population, and then finally we're going to take a square root. That's a whole lot of talking. Let's show it. Now you will see that I have lopped off some of the middle data just so I could fit things on the screen. But here's our quarterbacks, and just as a side note, the information was taken from profootballreference.com. Give them a click or two as time permits. And of course we have our completion percentages stacked in order of highest to lowest. And then we find our mean, which we'll then introduce into all of these columns here. And then we can calculate our distance from the mean, just like the formula suggested. We'll then square it. I'm going to take a second to talk about that for just a second. When we square that, you'll notice that we drop these negatives. Now for standard deviation, we're going to come back to the idea of plus or minus, but the idea of distance is really almost irrelevant when it comes to the direction. So Justin Herbert at 3.71 away from the mean really is pretty statistically similar to Derek Carr at 3.68 below the mean. Again, we'll come back to which direction when we see some more charts, but for now the idea is we just want to get that absolute distance. So once we get all of these, we add them all up, we divide by n, which is the population, or 33, which is the number of quarterbacks we pulled for this, and then we're going to take the square root of that. And that's really the number we want to focus on. Our standard deviation for our 33 qualifying quarterbacks is 3.169 or 3.17, which we'll use in just a moment. And that is, again, the standard deviation for completion percentage. Now, I'm not going to ask you to do this at all, but if you're inclined to try to start calculating your own standard deviations and aren't comfortable with the formula, If you're using Excel or similar spreadsheets, you can just use this formula. And when you get to the range of numbers, you just drag and drop over the numbers that you're going to use for that. Now you'll notice I do have two formulas. I did go with standard deviation.p, which stands for standard deviation of a population. The S stands for sample. The difference between the two is if you want to calculate the standard deviation between your entire population, if you have it, which is what I chose to do, or if you want to call that a representative sample, you would use that S instead of the P. So you'll start seeing everything gets color-coded on the following charts, and these are just our numbers to take a look at. So here's our mean again for completion percentage, and then when we start adding, these are going to be the distances we'll take a look at. And ultimately, what we're looking at here is the difference between this chart and this chart. Both show completion percentages for our 33 quarterbacks, but in addition to the mean, I've included our standard deviation in this direction, as well as this direction, and then our plus and minus 2 as well. And just a reminder of this bell curve, the idea here, again, is that most of our population will fall into the gray zone or that roughly average. All right, we've talked a lot of numbers. Let's talk about how we use this and what it actually means for analyzing statistics in the NFL. So here's our first conclusion. Standard deviation tells us not only what's normal, which is that gray zone, but what's truly remarkable. And so let's take a look at our far zones, our left and our right. Interestingly enough, on the right-hand side, even though Geno Smith was just shy of 70% completion and led the league this year, he didn't breach that standard deviation +2 mark, which would tell us that it's a truly remarkable season. So as good as he was, it's not anything that's statistically kind of crazier out there. Now, on the other hand, one thing I did include for this is standard deviation ±3, which, if you're doing the math at home, Zach Wilson actually falls 3 standard deviations below the mean for completion percentage, and I'm laughing because I know what that math means. So I'm going to lay that on you, and let's see if you can get a chuckle as well. I said about 2% of the population usually is plus or minus 2, so that 58.15 mark. So again, about 2.1% of the population, about 0.1% of the population, aka 1 in 1,000, ever falls plus or minus 3 standard deviations. So Zach Wilson had a year for the ages. Let's go with that. Now, conclusion 2 is why I started using a lot of standard deviation in analysis for football in the first place, which is just that it allows us to refine our zones. Very beginning of the video, I said using this exact measure of average kind of logs us into good versus bad. Well, with standard deviation, we can have meh, we can have pretty good, pretty bad, and then again, remarkable. And remarkable can be bad or good for our purposes. And standard deviation also leads to this conclusion. If you're trying to draw any sort of firm conclusion or assessment based on a single stat, you're running a fool's errand. So let's take a look at that with Josh Allen and Patrick Mahomes for just a moment. Now, you'll notice both of them fall in the gray zone, which would be considered our normal or pretty much perfectly average. Now, a few conclusions, sub-conclusions from that. If you had your choice again, Josh Allen and Patrick Mahomes, you'd go with the Mahomes completion percentage. So even within a category, we can do some kind of judgments or assessments based off of that. But when we take a look at our next chart, we see some things shift. And this is where that firm conclusion 3 really comes in, where you do need to take a look at a little more global data. So while we would have made the conclusion that Josh Allen and Patrick Mahomes were fairly mediocre quarterbacks from the last charts, we see that when it comes to yards per attempt, they both slide pretty drastically to the right side, which means that for this particular metric, they're both way different quarterbacks than what our first metric presented them as. If we were to add touchdown percentage, we'll see them shoot up the range even further. And if you watch my first video, the one stat to rule them all, I introduced an idea that the reason that we use these numbers is to kind of peer into the matrix and form shapes. So I want to combine these last two stats to make a quick judgment on Josh Allen. And if you want to check out to see if I'm right, go to Next Gen Stats and check out intended air yards. So with a low completion percentage for Josh Allen, but a high yards per attempt, the peering through the matrix conclusion would be that Josh Allen has a high intended air yards. Now, why exactly am I saying that? Remember that an incomplete pass, which would lower the completion percentage, also would lead to a 0 yards on that attempt, which would tend to lower this metric that we're looking at right here, or pull him over to the left. The fact that he's so far over to the right, despite having a relatively fairly low completion percentage, means that the passes he did complete were pretty far downfield. So again, go to Next Gen Stats, take a look, see if I'm right on that. And just because we want to, again, identify what's remarkable, I am going to point out Tua Tagovailoa. He broke the +2 standard deviation mark here, which means that he did, in fact, have a pretty remarkable season, throwing well over 8 yards per attempt. Now, that's good news for Dolphin fans for last year, but it's going to be probably good news for Bills fans next year. Why do I say that? One of the things that we can learn from standard deviation is what's statistically improbable to occur. Is it possible Tua is going to have another season like this? Yep. Wouldn't count on it, though. That's the end of our video. Don't forget to like, subscribe, check out BuffaloRumblings.com, especially coming up soon, as I'm going to be applying standard deviation for some combine data to maybe take a different look at some draft prospects.